Okay, 11.6. This week I am going to split Chapter 11, Lesson 6, into two separate parts. One with adding and subtracting fractions that already have a common denominator. And then on Wednesday, I'm going to explain how to add and subtract the rational expressions or fractions that have unlike denominators. And on Friday, we are going to do some long division with rational expressions. And it's kind of my favorite of the year. So that's where we're at for this week. Next week, I'll finish up Chapter 11. And then the following week, which is the week of May 18th to the 22nd, I am going to start Chapter 12. And then that's pretty much where we're going to wrap up the end of the school year. So really you have 3 weeks left. Some of you are ahead, some of you are behind. You're kind of all over the place. But that's kind of my layout so that I have time to get kids caught up, because my grading is somewhat of a nightmare with you guys turning things in at such random times. All right. So 11.6, adding and subtracting rational expressions. You need to remember your directions, I guess, for just adding and subtracting regular fractions. So let's just say I throw up on the top of this page something like 3/7 plus 2/7. You know your rules for adding fractions is that you do need a common denominator, the same expression or number in your denominator. So since I have 7s, I just carry that all the way through the common denominator. The denominator will stay 7. But then you add the numerator, so the 3 plus 2 is 5. Sort of like if you did have a pizza and it was cut into 7 equal parts, and you had 3 pieces out of the 7, or let's say you ate 3 pieces out of the 7, someone else ate 2 pieces out of the 7, together you ate 5 pieces out of the 7, or 5/7 of the pizza. Okay. So keep this general, pretty basic idea of adding fractions in your mind while we get into some more complicated material. So those directions just to add the numerators, to subtract the numerators. These are only the rules for having when you already have a common denominator. So let's look at example 1, letter A. The common denominator, look at denominators first, is y plus 5. So we're going to leave that y plus 5. When I say we're going to add the numerators, this is a 3y and that's a 4. You cannot combine unlike terms, but you can write it as 3y plus 4, right? You cannot make that 7y, or you can't make that just a 7 without a y. You just have to write an expression as 3y plus 4. This is as simplified as this problem can get, because this numerator is completely factored. This denominator is completely factored. If I speak of these numerators and denominators as factors, this is one factor, as is this. So you cannot cross off those y's. Okay, that is your answer. That is the simplified expression for that problem. Okay, letter B. Subtraction. Be really careful with subtraction. Denominators. 2n. That's going to come all the way across, common denominator. In this numerator, however, I'm going to write n minus 3, and then I am subtracting 3. I can combine like terms. Neither of those have a variable on them, so a negative 3 minus 3 is minus 6, or negative 6. Okay, so I just combine the like terms in that numerator. My n minus 6 is a factor. Okay, so I cannot cross off those n's. N minus 6 over 2n is my simplified expression. This is how I would write my answer. Okay, so you are adding and subtracting rational expressions and then writing your solution in simplest form, always in simplest form. Similar to when you ask me if you should reduce your fractions and I say always. Okay, so this would be your answer for letter B in example 1. This would be what you would write for your answer in example 1, letter A. All right, we have example 2, and then I'm going to add an example 3, just to see how this keeps going. Again, you can send me all kinds of questions if you'd like. All right, common denominator is, oops, straight line there. 2x squared minus 7x plus 5. I'm going to write the numerator as one big math problem. So 1 minus x plus 3x minus 3. I'm going to combine like terms in that numerator. So I can combine these. They both have a variable of x. So I can combine them. They are like terms. I am going to combine those. They do not have variables. They are integers. I can combine those. I'm just going to write below here. What's the assignment? Okay, so if I combine the x terms first, I have a negative x plus 3x, so that will be 2x. In other words, 3x minus x, 2x. Negative 3 plus 1, that's a positive 1, or 1 minus 3 will give me a negative 2. All over 2x squared minus 7x plus 5. Okay, I have added my fractions, but this is not in simplest form. So again, for reducing, and some of you are really struggling with factoring, so I put a review of factoring lesson on Google Classroom. You can also do all kinds of searching. YouTube, there's so many lessons. But simplifying rational expressions is what you would put in, or factoring rational expressions. Okay, so to factor this numerator, it looks like each term has a 2, so I can factor out a 2 as a common factor. If I do that, factor out the 2, divide by 2, I'll be left with x minus 1. Again, that x minus 1 is an entire factor, can't separate those two parts. And I need to factor this denominator. So factoring, when there's a number in front of the x squared that is not 1, I have to multiply the 2 times the 5, which is 10. I need to find two numbers that multiply together to make 10, and when I add them, we'll make this negative 7. So instead of 2 and 5, since they have to both be negative to add to negative 7, when I multiply them, they'll make a positive 10. They go to the middle here. This 2x squared you rewrite, the negative 2 with an x on it, the negative 5 with an x on it, and you bring down the 5, positive 5. Okay, so whenever there's a number in front that is not a 1, you will end up with 4 terms. Separate the first 2 from the back 2. Factor out any common factors, which looks like a 2x. Get x minus 1. Keep promising you that x minus 1 will be the same, or whatever's in the parentheses will be the same each time. Okay, so what can I divide out so I get just a regular x? I need to divide the negative 5. Then the two parts that look like they're just kind of separate hanging out, the 2x minus 5 will come together. I'm going to write my factored form up here. So 2x minus 5 and x minus 1. Well, now you can see, so factor the numerator, factor the denominator, factored form of the numerator, factored form of the denominator. But now you should be able to simplify in some cases. They have common factors. So my simplified expression after adding these two fractions is going to be 2 over 2x minus 5. And you can keep that in parentheses if you'd like. You can pause that. You can look at that entire problem. And I am going to do one more problem. So common denominator stays the same. Add or subtract any like terms so that this is written, combined like terms. Factor the numerator. Factor the denominator. Factor the numerator. Factor the denominator. This was factored form of the numerator. Factored form of the denominator. Cancel off common factors so that you have your simplified expression. Okay, I'm going to do one more that's as lengthy as that last one. All right, so I added this. This is not on your notes, but example 3. Okay, this numerator doesn't have any like terms, but I can write it as 3x minus 6. The denominator is the same denominator. It's the simplification part, simplifying this, that I'm worried about a little bit. So you need to factor the numerator, factor the denominator. And then we are going to cross off any common factors. And in some cases, I think in this assignment, I'm not sure, I'm just kind of thinking, but maybe this is Wednesday's assignment. There aren't necessarily always common factors you can cross off. So don't be surprised. However, you do have to write your answer in factored form. You can't leave this. You need to write it in factored form. Okay, so I'm going to factor this numerator. Common factor is 3. Okay, it's like the opposite of the distributive property. So if you don't know if you're factoring correctly, you multiply this back through 3 times x, 3x, 3 times negative 2, negative 6. You need to get this back if you multiply this out. 2 factors multiplied together gives you this result. Factor the denominator. There is no number in front of the x squared, so there's no need for me to create a 4-term problem like I did in example 2. I simply need to find the 2 numbers that multiply to negative 10, and when I add them, I will get a positive 3. Okay, you can see why I don't need to do that 4-part section, because when x times x, it'll give you x squared without a number in the front. So this should be 5 and negative 2. Okay, so I factored the numerator, factored form of the numerator, factored form of the denominator. Cancel or cross off common factors. Boom, boom. 3 over x plus 5. Ta-da. Okay, so that is today's lesson. I have split lesson 6 into 2 parts. There's your homework. It will also be on Google Classroom, but there you go. Like I said, I'm going to teach all 3 lessons today, post them. You can then pace yourself with the last one not being due till next Monday, a week from today. But I've had a request for some people to speed it up, so there you go. Enjoy the sun.